Okay, so we are ready to start now. So welcome to webinar of today with the name Complying Emission Targets with Optimized Cold Systems, which is also the presentation of a new generation of the ECOCURE Blue. um, my name is Pierre-Henri Vasselet. I'm the business line manager for Coldbox resins in Europe. I am very pleased to welcome you today to the launch of the second generation of the ECOCURE Blue, a best-selling cold box binder in Europe. My colleague Frank Lenson will explain in the next few minutes the technical and environmental benefits that ECOCURE Blue Pro will offer you. Frank Lenson is the technical product manager for cold box binder in Europe. He's a very experienced chemist who has worked for many years in the development of foundry resins and joined ASK 7 years ago to put his technical expertise at the service of customers and a product. So before we start, a few technical points on how the webinar works. Due to the data protection policy, your name, pictures, and camera will not be visible during the webinar. We invite you to ask any question you may have using the chat section, which should be in your screen in a green sections on the right side of your screens. We will try to answer them at the end of the webinar according to the remaining time we will have. The webinar is recorded and will be available on the website afterwards. So, in this webinar, we will try to explain a concept to help you reduce your emissions and reach your targets, and show you how a modern binder like the ECOCURE Blue Pro can help you reduce your cost by improving the production process and the quality of your castings. Finally, we will compare the performance of the ECOCURE Blue Pro to various other common types of cold box systems. So that is the agenda of today. So Frank will start by differentiating the different emissions in the foundry process. And then we'll explain how to reduce these emissions. He will then introduce a new ECOCURE Blue Pro and compare it to other systems. So we are now ready to go. I will hand over to Frank and wish you a good webinar. Have a good listen.
So this is Frank Lenson speaking. So also a warm welcome from my side. I try to explain to you the new system, and feel free to ask questions via chat also during this session, so that we can answer at the end of the session all your questions. So first of all, I would like to start with the theme emissions, which is the main focus, how we can reduce these emissions. And I know that foundries, especially in Germany, but also in China, for example, are facing several problems to stay within the limits, which is reduced every year. So let's focus a little bit on what emissions we're talking about. This is a sketch we've made for the European process, starting on the left corner down BAT guidelines, which are made in Sevilla. These guidelines are made from questionnaires, so foundries ask, what emissions do you have? And then they compare these emissions and define new limits. Finally, this leads to EU law. And then in national laws and guidelines, this is pushed and forced by worldwide initiatives, and also, I think you know it all, Fridays for Future. So a lot of private initiatives to reduce emissions. So what we're mainly talking about is these few emission types we have in the process, focused in this case on the cold box process. So we have mainly amine, CO2, formaldehyde, BTX, and also odor is coming up as a separate emission problem. And altogether, we have a summary value, so-called VOC, volatile organic compounds, so to describe all these emissions in summary, and also have a defined value for this VOC emission. So you can see this is a small sketch graph. The blue countries, for example, for the formaldehyde, have already limits. I'm sure that the other countries also have limits, but from these countries, I have significant and independent values. So you see that emission theme is all over the world relevant. So in Germany, usually we regulated our emissions, and Germany has a leading position in this emission game. So the values we define are mainly transferred to EU, and then finally leads to national guidelines in, for example, Austria, Finland, France, and the other countries. So this emission behavior is getting more and more also an economical factor. So you know that some, let's say, automotive companies former times forbidden the lead use in their process. So today it's not allowed anymore. I think it will come up with the same with the emission theme. So you're only able to sell systems when you can prove that you use a system which is producing less emissions or low emissions. So how is our concept, ASK concept, to reduce this emission? So mainly emissions are produced by using organic binders. You put the organic in the sand, making mixtures, and then it's set free. So I think you know from the metal side a system which is already establishing in the market. It's the so-called bionicle structures, which means you have not solid castings anymore. You're trying to reduce the weight of the casting, but keeping the structural strengths. So this is this bionicle approach from the structural, from the constructing side. Why should I do this? Yeah, sure. You have less cost because you have less weight of the casting itself, and you need less energy, and you still have high structural strengths. Maybe not the same with a solid part, but so reducing the material, the amount of material you're using is the same approach ASK is using for their binders. So here you can see a small graph. On the x-axis, you have the development time. So 16 years ago, we started with an addition level of 0.9 in the sand, so a high amount of organic binders in the sand. And you can see step by step, every step we're going down with the addition level we need for making good calls. So the last step now we're talking especially today about is this ECOCURE Blue Pro. So you can see the same principle, the less we can use here, the better. So we have technical advantages when we use the binder. The first one is reducing amine and also the gas defects and costs for sure. But there's also a sustainability advantages like reduced emissions, less energy consumption, and also improved CO2 footprint because you're needing less of the organic binder. And in addition, you have also cost reduction and easier way to recycle your sand. So let's look a little bit closer to these benefits. So let me give you a small example. Let's say you're using at the moment a standard binder, and for sand mixture per kilogram, you use 7 grams of part 1 and also 7 grams of part 2, and additional, you have to use 0.4 grams of amine. So with ECOCURE Blue, you can reduce the binder level and also the amine level, which means then 30% binder reduction and also 25% amine reduction. So this is a reduction of amine, and if you also improve the process, you can go up to a level of 50% less use of amine than with a standard system. All these benefits reduces then your emissions, and again, lower costs, lower CO2 footprint, and also improved sand recycling. So just by reducing the binder. In addition, you have also other positive effects, but if you only simply look at the addition level you have to use to have the same technical strengths, it's already a benefit. Let's continue this example. We have now reduced the binder level in total in the sand binder and amine from 14.4 grams to 10.3 grams. So we have less binder. And this leads also for sure during the casting process to less gas volume. Less gas volume means reduced tendency of gas defects. So you can expect that your castings, especially when you have facing gas defects in your normal process, will be significantly improved when you switch from a standard binder to ECOCURE Blue Pro. And again, you have reduced emissions, costs, CO2 footprint, and all these positive effects. So summarizing this small example, you have 25% amine less, which leads then to specific advantages like less energy for curing, because less amine means also less heating. You have longer service life for the amine scrubber, because less amine means also less acids to have on the counterpart to consume the amine. You have less smell and direct emissions. So maybe you can modify your venting, and also your employees will like to have less amine in the air. On the other side, we have a reduce of binder, which leads then to better flowability, less sticking in your tooling. And this maybe leads to the way that you can reduce your shooting pressure and also increase your cleaning intervals of the tooling. So these are more or less specific advantages per part. And then you have in total, for sure, also positive cost effects. So less binder means you have to less transport costs. Less orders means less transport costs. I already talked about the reduction of binder of organic material, which then leads to less gas defects. So another benefit, less casting defects. On the other side, you have costs to deposit the sand. If you have less organic and less toxic organic in the sand, it's easier to deposit the sand, because for sure it's cheaper when you have less toxic material on the sand. So overall disposal cost will be lower. So a lot of good cost arguments to use a new binder system. So let me give you a small overview about the systems we can offer. You mainly want to talk about this ECOCURE Blue Pro, but for sure we have also other systems in the portfolio. You see there's two indicators. One is environmental and one is performance. And with ECOCURE Blue, you have a really good compromise with low environmental issues, and at the same time, you have a really good performance. Nevertheless, there are other systems on the market and also from ASK, which are needed for the production and also for the process. But we want to talk about mainly about EcoCure Blue today. So let's talk about specific EcoCure Blue Pro. So we're coming from a standard binder, and in the standard binder, you have several substances which are here indicated in red, which are not really healthy. So, and they're maybe disturbing your curing process. There may be solvents which are smelling. So all these yeah, complicated and unliked ingredients we eliminated already with the EcoCure Blue. But even more, based on this EcoCure Blue, we're tried to develop the next level, the next step, this EcoCure Blue Pro. But in principle, we have this blue technology developed, one step further. So here you can see how we developed this EcoCure Blue Pro. So we started with EcoCure Blue, and this is a system we used at about 120 clients in Europe. Not all of them are buying this EcoCure Blue, but a lot of them. So based on this experience with EcoCure Blue, we asked customers, what should we improve with this system? And then we found that they are looking for, even if they have a good system with this EcoCure Blue, they are searching for higher reactivity. So to speed up the process, getting faster, using less binder. And on the other side, we have the emission task we talked about. We have in Germany the new regulation 1 year ago, where the limits were significantly reduced. In the process, there was a requirement for less sticking tendency and also a better cold storability, especially for the Northern Europe area. We had to improve this EcoCure Blue. And also a reduction of total cost of ownership. So cost is always an issue for foundries. So based on these requirements, we developed first a new basic resin, already based on the experience on the EcoCure Blue, but there was modifications necessary. Then we started an optimization in the dilution process, so solvents were searched, and then finally we adapted the part 2, so the isocyanate part, and finally we tested the performance. So the result was then the EcoCure Blue Pro. So EcoCure Blue Pro is, let's say, tailor-made for the requirements which our customers are at the moment searching for. So this is, if you compare with other systems, one of the benefits of the Blue family, and for sure also for the Blue Pro. So it's free from pictograms. So it's no hazardous substance per definition. So you can store, I don't want to say wherever you like, but this is the only material on the market which is not hazardous anymore in palm 1. So here you get an overview about the emissions, and this is the answer for the question, why is this low phenol and low emission important? Why do we need this? On the left side, you see a regulation based on the German law, and these are the main substances in the process where you have to look at, and also the limits, which are in German in force and also in several European countries. And you see that there's, for formaldehyde, for example, in the whole process, so during the mixing, during the core making, during the core storage, and during the casting, this substance is relevant. It's the same with the phenol. The phenol you have in the mixing process, the problem, and also in the casting process. So phenol and formaldehyde are toxic substances and can harm your organs. And this is the reason why usually in every country there's a limit for these substances. Phenol can be released, as shown here, during the mixing and decoring process. And formaldehyde can also be released during the complete process. So we had to get rid of these substances. So on the other side, we have this phenol in this waste sand side. So on the waste sand side, phenol is also a relevant parameter. So phenol and phenol index can lead to problems when you start to deposit the sand. At least you have to pay more for it if you have higher values in the sand. So target is to reduce the phenol also in the waste sand side to make it easier to deposit the sand. So strategy is no phenol, no formaldehyde. And this is with the modern systems, with the blue technology, state of the art. This is what all suppliers on the market try to reach, and ASK already today is able to deliver such systems. So this is state of the art. The old systems are not requested anymore. So the next question is, can we use this binder system for every casting? Yes, mainly yes. You can use it in iron casting, steel casting, also brass. It's no problem. Problem is it when you use it in die casting due to the solvent package we have in. Here you have a better choice. We have this ECOCURE silver and silver T. It's the same technology, but different solvent based. So this is for die casting, the better choice. For aluminum sand casting, for sure, you can also use this ECOCURE Blue and Blue Pro. So let's talk about this modular system. We have some part one, which we can offer. This is ECOCURE Blue Pro 30HS10. And then we have several part twos. So why several? Because depending on the needs of the customers, we can offer different behavior. So first of all, we have this standard application. So this is used for the main applications. But if you need, maybe due to a situation that your reclaimed sand has green sand inside, which is happening sometimes, you have to use a different part two. So this can compensate not everything, but a lot of different problems with reclaimed sand. Or if you have, let's say, aged tooling, so the surface is a little bit rough, so we have problems with sticking, then you have another part two. Or we find a compromise between bench life and sticking, then we take another part two. And even if these are not suitable, we are able to develop an individual part two for your process if necessary. So this is always the same part one. So without hazardous indicators, without phenol, without formaldehyde, and then several part twos depending on your process. Let me give you a few rough information about the technical behavior. Starting with this diagram, which is a little bit technical. So on the x-axis, you had the information about the addition level. So 0.5 to 0.7 means 0.5 part 1 and also 0.5 part 2. And on the right side, it's the same 0.7 part 1 and also 0.7 part 2. So you can see that with increasing the binder, the strength is also increasing. This is what you can expect. But you also see that the different binders, so we have three here. The green one is the ECOCURE Blue, and the purple and the orange one are systems which are on the market from the competitors. You see that there is a significant difference in strengths. So the question would be, if you work today with a standard binder on a level of 0.6, And you're getting 140 Newton per square centimeter after 15 seconds, which is indicated here in the diagram. How much of EcoCube Blue Pro do I have to take to get the same strengths? And mainly the out-of-the-box strength is one of the most important ones, because if you want to have productivity, the productivity is relating to how fast can I take the core out of the box. So immediate strength is quite important. Again, how much EcoCube Blue do I have to take? Quite easy. You can see it here, about 0.5 each part to get the same strength. And in addition, you can also reduce the amine consumption, because less organic in the sense means you need less amine for curing. So another point is then how much less amine can I use? So here we have a diagram on purple. Standard systems is the amine in grams per kilogram core, and you see a variation which is coming from practice. With EcoCube Blue, the first step, this is the one in the middle, you're able to reduce already up to 50%. And this is a variation our experience we find when we use EcoCube Blue in practice. So this large amount of customers which are already using were able to reduce, in the most cases, the amine consumption. And starting from that point, you can reduce again with EcoCube Blue Pro the amine consumption based on the reduction of binder in the sand mixture, but also to the improved reactivity. So this is a diagram which explains the gas reduction effect. So the purple curve indicates the gas defect during the casting process. So in the first 3 or 4 seconds, you have a significant gas impulse, which is then leading to gas defects. And with the green line, which is showing the values from EcoCure Blue Pro, you can see that this impulse is significantly reduced. And also the condensate, so the tar which is built up during the casting process, is significantly lower. So with EcoCure Blue Pro at 0.5 per part, compared with a biodiesel binder, 0.6 each part, you have a significant reduce in the gas volume and condensate in the first 20 seconds of the casting. So the gas volume is then minus 50% and the condensate is minus 15%. And you know that the gas defects, you're the foundry man, for sure are responsible for these unlike defects here. So to prevent these, a reduction in gas volume will be the right way. Okay, so for those which are already using the Blue technology, why should I use this Blue Pro technology? What is the difference? So again, a few technical slides. So here you can see a comparison of bending strengths based on silica sands. So we are taking Blue and also Blue Pro at a level of 0.6 each part and compare the strengths. Again, the immediate strengths on the left side after 15 seconds. So this is responsible for your productivity. Also the 30 seconds, the second bar you can see. And then till 24 hours, and also the last bar, 24 hours at 98% relative humidity, you can see that Blue Pro is always better than your already used Blue system. So we have between 10 and 20% more strengths So this leads then to the reduction of 10% based already on the ECOCURE Blue. This is the bench life. So if you have the sand mixture in your hopper and your core shooter, it's aging. And if you have a problem at the core shooter, maybe with an old system, the older system, and the blue maybe also, you have to clean your sand bunker. You can also see that with ECOCURE Blue, again, here's an improvement. So we have higher strength even after a storage of 2 hours. So we let this sand mixture 2 hours in the sand bunker and tested the strength level. You can see there's also a significant better behavior. Again, 10 to 15% better strength at the same binder level. This is then the coating compatibility. So you can see that the coating on the wet core, on the hot core, and also after the cooling process, so drying, simulated drying process, you have an improvement of the EcoCure Blue Pro system if you compare it to the Blue. Blue Pro in green, blue in blue. So, and here we have the deformation tendency. So this means you coating a core, so water is always disturbing the curing process, and you put it on a rack maybe to dry it or to transfer to drying oven. And if your complex structure is pushing or pulling on the core, it's maybe deforming. So it's, the deformation, which we measured here, is relevant for this process. So you can see with the standard system, the purple one, you have a deformation of 1.1, about 1.1 millimeters. With the blue, you have only 0.5, and on the same level as the EcoCure Blue Pro. So very low deformation tendency, which is very good for dimensional accuracy. And yeah, it's definitely a pro for the Blue Pro system. But so the first slides are based on the German H32 sands. And these diagrams are now indicating the different source, different sand types you can find on the market, a few ones. So this is a Spanish one, Arena C60. You have the comparison between the both systems, Blue and Blue Pro. And in addition, you have a third bar, which is then indicating the strength behavior when you reduce already this 10% binder. So you can see that there's, even when you reduce the binder, you're still at minimum at the same level than was the old system with the EcoCure Blue. So this is based on the Spanish sands. Then we have based on this LA32 sands. And again, the same behavior with a reduced binder level. You're at least at the same strength level that was the old system. So 0.7 was old, 0.65 with a new system. And also again for the immediate strengths and also for the stored cores. So again, here's the bus carb sand, which is also in the Northern Europe area, more or less common. And again, you see that there's a improvement with the new Blue Pro system compared with the Blue system. So it's the same picture, Blue, Blue Pro. Blue Pro has higher strength, so I'm able to reduce the binder, and still I have higher initial strength than with the old Blue system. And over the whole curing process, we have this benefit of about 10%. So this means the Blue and Blue Pro system are suitable for nearly every sand type you can find. and we have better performance, at least the same with 10% reduced binder than with the old system. So let's summarize first one. So we have no hazardous product in part one. So it's free of any hazardous indicators. So phenol is below 1%, formaldehyde below 0.1%. This Blue Pro has been improved in storability. So this binder is stable till a minus 20 degrees centigrade. So again, especially for Northern Europe area, it's quite good. We have higher strength levels with ECOCURE Blue Pro than with Blue, and for sure also with other common systems. Compared to Blue, we have 10 to 20% improvement. If you compare it to standard systems, I think the improvement will be even higher. So the binder reduction we can establish with the Blue Pro leads then finally to reduced emissions. We have reduced gas defects or reduced gas potential, which is leading to lower gas defects. We have less organic, which means less sticking. So there's another benefit. You can maybe reduce your release agent, the amount of release agent you use. You definitely can reduce the amine consumption. It's another cost factor and also an emissions factor. And you have a significant lower leachable phenol, which is for the deposit side, definitely a good argument. And compared to the ECOCURE Blue Pro, when you know this system already, there are no withdrawals based on this older system, ECOCURE Blue Pro. So, conclusion. So we have a highly efficient technology with this ECOCURE Blue Pro, which is state-of-the-art technology. You can use less binder, less amine. I talked about a few times about this issue here. You have great performance. If you compare also to systems which are on the market would have good performance, this system is even better. You have improved strength, less sticking, which is good for the productivity and also for the costs. And you have an improved sand flowability because, again, when you lose less organic on the sands, this also blocks the flowability. And if you reduce the binder amount, this will also improve your sand flowability. So on the other side, you have the option to reduce your total cost of ownership, so your process costs. So less energy you have to use in the process, less heating of amine, less use of amine scrubber. You have less energy costs, again, less amine, less heating, less rework. If you have better castings and you were able to prevent the gas defects, you're getting more good castings at the same time. So higher productivity because the initial strength is quite high, so production cycles can be shortened. Less cleaning, less organic means less sticking. So again, productivity arguments. And no investment needed is in brackets because depending on your process, if you're able to reduce binder and amine, maybe you're in a situation that the emissions are already on a level that you don't have to invest in a very cost effective or cost level of secondary heat treatment to reduce all the emissions. So no investment is in brackets because it's depending on your foundry and the size, geometry of what you're casting. But for sure, the emissions will be reduced, and then maybe you don't need any more heat treatment or air treatment to reduce emissions to a level that you can fulfill the needs from government. On the environmental side, again, you're reducing the emissions. You have no hazardous labeling. You improved your OEL level, so the workers will like that, and you will, yeah, secure your workers for emissions from organic binders. Again, less energy consumption. Energy is quite expensive. You're improving your CO2 footprint, and you can also improve your recycling system, so less organic on the sand also produces less waste in the recycling process of the sand. So for now, I'm done. And if you have now questions, feel free to put it
Yeah,
in the chat.
thank you, Frank, for the presentation. So I think that we still have a couple of minutes, a little bit more, maybe 5, to answer the different question we have. So first of all, I would like to apologize to some of you because some have had some disturbance with the sound. So okay, I think that the most of you answered that they didn't have any problem. Um, so the question, I think that the first question is for you, Frank, concerning VOC emission. Is there a general rule between the percentage of binder and the milliliter of gas generated?
Yes, as I already showed, the amount of organic you put in the sand will definitely lead directly to a volume of gas. Yes, it's not 100% calculatable, but you can, if you look at the same binder with the same solvent package, the amount of binder will lead definitely to lower um, volumes of gas. If you look at different solvents, depending which solvent you use. So let's say in general, yes, there's a rule. The lower the binder level is, the lower the gas during the casting process will be.
Okay. Another question, does you as suppliers have a regulated standards for how to measure the binder system's performance and emissions? It is often not clear for customer how to compare systems since no supplier present data in the same way.
Sorry, it was too fast. I'm trying to follow the question. It's a long question.
So does you as supplier have a regulated standards for how to measure the binder systems, performance and emissions? And the rest is a comment. It is not clear for the customer how to compare systems since no supplier present data in the same way.
Yeah, that's right. So performance, yes, I think it's more or less standardized. In Europe, it's common to use bending bars, and the equipment is standardized. There are rules for that. Emission is a little bit a problem. I think there's no defined process for the emission tests. I think all of the suppliers are trying to do their best to get reliable results. But yes, to do this emission tests in the lab are not 100% comparable to what you do in practice. So the best is to measure directly in the foundry, at the foundry, and to get values directly from the customer. ASK can support you there. Yeah. On the other side, we have lab tests developed, which trying to, again, do the best to get reliable results. But there's no standardized system.
Okay, so the last question for today that will be what's the phenol and formaldehyde level of EcoCure Blue compared to EcoCure Blue Pro?
It's an easy question or easy answer. It's the same level. So the issue is to get below 1% phenol, because then, per definition, it's phenol free. It's the same with the formaldehyde. If you're below 0.1% formaldehyde, per definition, it's formaldehyde free. And this is for blue also, then for Blue Pro. It's also for the silver family, which is also coming from this blue technology. So silver, silver tea, so all the other products have the same idea: no phenol, no formaldehyde.
Good, thank you. So we are now coming to the end of our session. We invite you, if you are interested or if you have some other question, to contact Frank or your usual ASK contact person to learn more about the subject. Um, yeah, you will also find our website additional documents and information on these and other products and services that ASK can offer you, as well as a newsletter to which we invite you to subscribe. And of course, we hope to see you all on a booth at the GIFA in June. This will be a good opportunity for you to meet Frank and the team and to learn more about the EcoCure Blue Pro. So thank you again for your attention, and on behalf of ASK, I wish you a very nice day. Bye bye.
Yeah, also bye bye from my side. Thank you for listening.